will be sitting here somewhere, or maybe not since it'll get rained on. Yeah.
We might have to
find a home for it. But I'll just kind of run through what I put in the binder. The first thing I've got in the binder is the PPE for these chemicals. The Optisperse. This is Optisperse PO 50715. This is the phosphate product that he was talking about. This is it's got a phosphate and a polymeric dispersant inside of it, and that's what'll it'll get rid of the hardness. It'll settle the bottom. That's why you got to do the bottom blowdowns and be diligent about it, because all the hardness in the water is going to settle to the bottom as it mixes with this phosphate, and then the polymer will help flush it out. But for this, there would be rubber, butyl, Viton, or neoprene gloves, and splash-proof chemical goggles. So not too hazardous of a chemical, really. And I'll be getting, I have labels on order too, and I'll be putting those on here that'll actually tell you what the PPE is for each chemical and have the kind of a breakdown of the hazards associated with it. The Cortrol IS3000 is your sulfite. That's the oxygen scavenger that feeds into the feed water. It is used to remove that last bit of oxygen that the feed water tank cannot remove. But typically, Deaerators remove nearly all of the oxygen, depending on what it's rated for. And then the sulfite gets rid of the last little bit. Again, you want to wear the gauntlet type rubber, butyl, or neoprene gloves. This one requires a chemical resistant apron, splash proof chemical goggles, and a face shield. So a little more hazardous than the phosphate was. The Steamate NA702 in this tank is your neutralizing amines. So that's what's getting injected into the steam header. It's volatile, so it will go with the steam and it will get condensed, and that's what you'll see coming back with the condensate that'll bring the pH up, and it'll keep your system pH elevated where it needs to be. This one would be, again, neoprene gloves, a chemical resistant apron, goggles, and a face shield. Move on. And then I've got the MSDSs for each chemical in here to refer to, just in case there's ever any questions about the hazards. And as far as filling the chemical tanks, what I've done, because this boiler shouldn't need very many chemicals, I put in a gallon of each chemical and then 10 gallons of DI water, and we'll see how that balances out and as the system's running. But you know, looking around over here, it looks like it's going to be difficult to get DI water to dilute. And there's no soft water running to these tanks. You could mix it with condensate, but I don't know if there's a condensate line in here.
So you have to dilute the chemical?
You don't have to. You can feed it neat. That's fine. It may be that the feed rate will have to be so low that these will be dialed way down and the pumps will be dialed way down, and that'll, you know, we'll see how it goes with the analysis. The analysis at the beginning is going to be more frequent until we get a feel for how it's all going to balance out.
Did you do the dilution with all three chemicals?
Yes.
And is that ratio in that book? One
No,
gallon of chemical to how much water?
Well, 9. So a total of 10 gallons. So.
Oh, total.
Yeah. But I have not put the ratio in the book because I want to see what it does and how feasible it's going to be to even get DI water over here to fill this on a regular basis.
There's no DI water up there, is there?
Well, it's man-made. Yeah, it's sort of DI on the roof of the west here. It's Siemens, yeah.
Siemens, the one.
Services, yes. Yeah, they do.
Siemens?
Yeah, yeah.
So well, maybe we can put one station here. Get the Adam.
No, we just put polishing bottles down.
Because we need the DI water.
It's gonna require DI
can we,
water, I believe.
I don't know. You fund for that?
A small station, that's,
What quantity?
They have like a filter bottle.
yeah.
Get the polishing bottles and just kind of make our own DI.
Yeah, and soft water would be fine as well, but there is no softener on this system. Condensate is okay if there's a port over there somewhere on the condensate line.
Siemens guy.
Siemens could certainly provide a bottle. We could probably arrange to have a bottle put out here. Or feed water is okay too. So you could always take some boiler feed water and put it in a tank.
Probably we need the water so in order to dilute the chemicals. So either one, you put it in, then we pick it up and maintain it.
And we'll see, you know, as time goes on, just how dilute it needs to be. But these pumps probably are not going to run all that often because the usage is just not going to be there. I've also attached or put in the binder fact sheets for each chemical. So as I explain the chemicals, you can always refer to the fact sheet that kind of explains what it does, what the typical control ranges are. Again, I guess we'll start with the phosphate. Again, we'll go back to this, and the phosphate is feeding into the feed water line over this way. So it's going into your boiler feed water system, and then it's going to go into the boiler as the boiler makes up with feed water. And we're looking to keep the feed water phosphate between, I've got actually the recommendations in this binder as well. So we're looking for 40 to 70 ppm of phosphate in the boiler, and if 40 to 70 ppm of phosphate in the boiler, and where I had sampled from when I started everything up is, I know he kind of went over it, and I was over around the corner, so I didn't know where he was showing you guys exactly. Normally, okay, so I grabbed it from here, but typically there's a sample point, you know, on the boiler specifically for that, for sampling, but there's not one here right now. So I grabbed it from there, and then if your phosphate comes out low, you can either increase the pump setting, the pump stroke, the pump speed right there, or this timer is hooked to the makeup meters over here where the city water is coming in, or the industrial cooling water, and as it makes up, it keeps track of the number of pulses, and based on the number of pulses that it sees, it tells the pump to stroke a certain number of times. So if you go into the menu, you'll see timer 1, it's set to pulse, and on in 1 pulse. So for every pulse of the meter, you'll get a pulse of the pump.
1-to-1 ratio.
1-to-1 ratio right now. I was just kind of blowing the boilers down and just to watch and see how often or how much water it would take to get them to come on. It takes a while before they even come on, and then I just wanted to make sure I wasn't overfeeding, so I watched them run. And this timer is controlling the phosphate pump. Then the next chemical, talk about the Steamate Na702. Like I said, it's the neutralizing amine. This chemical feed line is running up to the steam header. You can see it running through the conduit. It says amines up there on the conduit. This is it's a blend of a couple neutralizing amines. Like I said, it will keep the pH of the system up what you'll be looking for is the pH in the feed water. Make sure that's staying in spec, and the pH of the boiler water. So if you get high or low, again, you could either adjust the pump stroke, or you could adjust the pulse ratio. And then the specs on that, you tab 10 here, and this is boiler water pH is 10 to 11.5, so that should naturally cycle up. The Hetchy water is very pure as far as city water goes. It's a extremely pure source compared to most water you'll see. There's not much hardness in it. Maybe that's why there's no softener on this system. But what you'll see, especially in the winter, probably when this will be running most of the time, you'll get a blend when they do work on the Hetchy line, and you may get sometimes 6 times as high conductivity, or TDS, in the in this industrial water coming in. So the spec on the well, it says soft water. There is no softener, but basically the feed water, as outlined in this, is 1 grain per gallon, which is 17 ppm of hardness. And Hetchy normally is below that. It's normally close to about 10. But as you get into the time of year when they're doing some work on the water lines and blending in other water sources, you may actually exceed that. So that may be a reason to install a softener. But cycling the boiler up with the based on what the alkalinity in the feed water is and what the pH is, the boiler water will cycle up as well, and you'll be able to get your pH and alkalinity come up that way. Or you can feed more neutralizing amines to the feed water or the steam header, which will eventually come back to the feed water through the condensate and into this system. Now I will say too, you mentioned it's a very closed system, so another reason it may not need a softener, if you're getting a large amount of condensate back, there's not going to be any hardness, we hope, in the condensate, so it'll keep the feed water solid. So hopefully that'll be the case.
I have a question. Are you going to be doing the monthly analysis?
I'll probably be out here every couple weeks to take a look.
On the report, is there any possibility of taking a sample at the hose bib for softness? Just so if there's a red flag, if it ever does get to be really high?
Yeah, so it's like the city water coming in?
Yeah, versus the odometer reading on the meters, just so they know if they're taking on a lot and they know if it's hard, then they know that
Right.
they need to get an exchange unit out here temporarily.
Right.
Or whatever.
Right, but like I said, if they're getting a lot of condensate return, even at its hardest,
Yeah.
it may be keep the water soft. But then if you lose condensate for some reason, for some work, then all of a sudden you're on 100% makeup. So, it's like you said, there may be cause for installing a softener, if only for those occasions, and for filling these tanks to dilute them. So that covers the Steam 8. The other one we'll go over again is the sodium sulfite. This is going to the feed water tank. Like I said, it scavenges the oxygen. There's kind of a balance between the sodium sulfite, since this is all split in 3 different tanks. Sometimes you can get it all in one chemical, but this gives you more flexibility as controlling specific chemicals. But the sodium sulfite is acidic, so if you overfeed into the feed water, it will depress the feed water pH after it overcomes the alkalinity in the makeup water or the city water. So if you ever get a low pH in the feed water, it could be because this is high. And the sulfite, you'll actually be checking in the boiler water, and you're looking for a sulfite residual in that boiler water. Yes?
Hey, we have a question on the sodium sulfite and the phosphate. Aren't they supposed to be, I have 2 water meters, and one's supposed to be for the amines, and the other one's supposed to be for the sodium phosphate, sulfate, and the phosphate. Aren't they supposed to be plugged into the 1 meter right there, and the amines by itself?
Well, they're all
Yeah, I think.
they're all based on the same
same
incoming
amount of
water.
makeup.
Yeah, I mean they're
But are you triggering your timers? For
there's 2 timers on each, so there's a separate timer.
Okay.
So this is complete.
All I
This is
know
controlled
we have
differently.
Another meter just for the amines, so.
Yeah, yeah,
Well, what
that's
happened was we sold the first one that was just sulfite and phosphate, and then the amines was added as an afterthought, so.
Yeah. But it doesn't matter if they're plugged in one.
No,
No,
it's
'cause-
separate timers.
yeah. They have separate timers, so they'll do their own pulse counts. And you can also the other adjustment you can make is the duration of feed. So right now they're set to feed for 30 seconds when it's told to pulse, but that's another way you can manipulate it and change the feed rate. But yeah, like I said, just we have to be careful with this. If there's a bunch of sulfite overfed, then you can depress the pH. So that's something to be careful about. You can counter it with neutralizing amines, but the way it's set up with the amines going into the steam header, you have to get the condensate back to get the amines. So again, if the condensate was offline and being dumped somewhere and not coming back to the feed water tank, you lose the amines.
Other question. The way I have it set up, if you look at the sulfate and the phosphate, see how the motors are mounted next to each other? I'd like you to plug in the sulfate, the sodium sulfate with the phosphate, because it'll look better. Please, that's the reason why I did it. So that way, those 2 are going to that one controller, and the amines is going to the other controller.
Okay.
If you could, please.
Sure. No problem.
No, it wasn't a question. I did it on purpose. I just thought about it. Yeah. Spiced up.
So,
But I did.
and I just wanted to cover kind of the reasons why we add these chemicals. The reasons for boiler water treatment. One, for the scale inhibitor. You don't want scaling in your boiler. You lose heat transfer efficiency. You'll get a bunch of sludge building up on the bottom. That's why we have to make sure we're bottom blowing. We want to prevent corrosion in the feed water system. So all these components here leading up to the boiler, those could be susceptible to corrosion. So you want to make sure you're keeping the feed water pH in spec. And want the steam to be high quality steam. The effects of poor boiler water treatment would be operational upsets. The unit would have to come down. Safety, obviously we don't want to get in a condition where a tube overheats and you blow something up. Cost associated with the maintenance and repairs. Reliability, everyone's going to want their heating steam. And then regulatory compliances as far as what we're discharging. There are discharge limit specs on the Stanford campus. I know sometimes there's some exceptions made depending upon how that's worked out, but nothing lower than a pH of 4 is supposed to ever go to the drain, and nothing higher than a pH of 11. So, like I said though, sometimes that's worked out with environmental, and you can get exceptions to that.
What is the pH of your phosphate?
The
When it's mixed with the boiler water, like what is it supposed to be?
The boiler's going to be 10 to 11.5, so we'll have to limit it to 11 unless there has been something outlined from Stanford EH&S that says 11.5 is okay. I mean, like the central plant runs their boilers at 11 to 12, so there's no issue. But you know, there's an exception made there, and even if it's coming out of here at 11.5, like the spec as outlined by the boiler is 10 to 11.5. It's going to mix with that water, the water to cool it down. So when it comes out the drain,
Diluted.
yeah, it'll be well diluted. And the other thing about this, specifically about this water source and around this area with the Hetch Hetchy water, it's actually, considering its conductivity, very alkaline. So it does have some resistance to changes in pH, and it, like I said, it's extremely good quality. And you'll see the pH of the water actually coming in is actually usually about 9, which is pretty high for a normal city water source. Basic steam cycle, pre-boiler, which is your whole feed water system. Going to the boiler, you got your steam from the boiler, and then you're getting your condensate back to the pre-boiler system, which is your feed water tank. Inverse solubility, that's why calcium and hardness becomes a problem, or calcium and magnesium. They're inversely soluble, which means as the water heats up, you know, you kind of think of, you start putting stuff in water, you boil the water, everything kind of dissolves. But in this case, hardness, like calcium and magnesium, becomes less soluble and is more susceptible to attach to things as the water gets hotter. So that's why we got to keep the hardness from depositing. Feed water deaeration. Pressure deaerators are typically 10 to 50 ppb DO spec. I'm not sure what the spec on this one is. Do you happen to know?
Less than, what's the standard, 5,
I forgot what it is.
ppb
no.
or milligrams per liter?
I'd have to look, I don't remember, to be honest with you. But
Okay.
it meets the industry standard of the,
Okay. So like I was saying, the DA typically removes, a well-functioning DA typically removes almost all the dissolved oxygen. And then you only need a little bit of oxygen scavenger, in this case sodium bisulfite, to remove that last little bit. You'll always want to make sure that the DA is vented, so you'll want to see that there's actually a little bit of a steam plume coming off the DA. That's how the oxygen is getting out of there. And the steam is coming and kind of scrubbing the atomized water to lift those dissolved gases out of the DA. So that's just something to keep an eye on. If there's something, if the vent's not open, you'll might have oxygen issues, or if the vent or the steam pressure is low and you're not getting much out the vent, it might not function as well. This is kind of what dissolved oxygen can do. Dissolved oxygen is probably the worst condition that high dissolved oxygen is probably the worst condition you can get in a boiler system. Dissolved oxygen corrosion is highly localized, so you will not see a general corrosion, which would take more time to cause an issue. Localized corrosion like dissolved oxygen finds a place to activate a corrosion cell and then starts working away at that specific spot, and it'll drill a hole sometimes in a matter of a couple weeks if the dissolved oxygen is really high. So another reason we want to make sure that there's no oxygen getting to the boiler, and then you have a sulfite residual in the boiler. So we got the other thing to control is pH, like we said with the Steam 8 NA702. 8.3 to 10.5 is a wide range that really works well to control corrosion rates for mild steel. And when you start getting copper into the mix, which I'm not sure if there's any copper metallurgy out in the building that we need to know about. But then you have to be careful about approaching a higher pH. But for iron, up to 10.5 is fine. And in the boiler, even up as high as 12.7. We'll never get there. But 8.5 to 12.7, and the actual specs will be outlined in tab 10. Carbonic acid can get into the condensate system, which will depress the pH of the condensate unless there's neutralizing amine. So depending upon, we'll have to find a place where we can get this condensate sample. I heard it's probably down in the building, not so much over here. But we'll want to be able to keep an eye on that, because it's a way to say, hey, the condensate pH is low, I need more neutralizing amine. There's the corrosion of steel versus boiler water pH. You can see low pH is extremely bad. Start getting up around 8 to 9, goes down, way down, and then even up to that sweet spot like I was talking about, 8.5 to 12.7 or 8.3 to 12.7 is that sweet spot for carbon steel corrosion rates. So we want to minimize deposition, minimize corrosion by properly feeding the chemicals to maximize reliability. Again, so with the Cortrol IS3000, the way you test this product is by that sulfite residual in the boiler blowdown. So when you grab the sample from there, they'll take it. And it's another thing about this boiler right now, without a sample cooler, you can't do all this analysis with it hot. What I've had to do is bring a bucket and then run it under city water and carry my bottle that I collected the sample in over to the bucket and let the water run over it for a little bit to cool it down. And then the first thing I check is the sulfite residual, because as soon as you open that bottle and expose the bottle to air, the sulfite in the water is going to start reacting to the air. So that's the first thing you want to check. And then conductivity and pH, because you can check it real quick with a meter. The Optisperse P050715 will be checked in the boiler water as well. So you'll be looking for phosphate in the boiler water. And it actually has to be filtered through a 0.45 micron filter, because we want to see how much soluble phosphate there is. And then the condensate pH, like I said. So we'll have to find a place to get that sample and make sure that the condensate coming back is good quality. Now, with a high condensate return rate, you'll know by the feed water sample if you're getting enough amine in there. Boiler feed water controls that typically what you test for in the boiler feed water: conductivity, pH. So high conductivity in the condensate could either be caused by a leak in the condensate system somewhere, where you have another source of water on the other side of that condensate that's getting into the condensate and coming back. Low pH would mean you're not feeding enough Na702. High pH means you're feeding too much, and you'll also see the amines increase the pH of the condensate. So if you get a high condensate pH and a high condensate conductivity, then you can attribute both to the overfeed of Na702. Total hardness. We want to check, like I said, the spec is as outlined by the parameters. It was 1 grain per gallon or 17 parts per million. So it's just another thing we're going to check in the feed water to make sure there hasn't been some sort of hardness excursion, so that we're not sending hard water over to the boiler. Iron gives you an idea of any active corrosion going on, and then Also, the you don't want to send too much iron into the boiler and expose that to hot surfaces, because that can start plating out. And then, ideally, you would be able to check dissolved oxygen coming out of the boiler feed water. We will have to do some sort of modification to be able to get a dissolved oxygen sample. We want to be able to see how well the DA is working and how much dissolved oxygen is actually in the feed water. But that has to be a cool sample, and it has to flow for a while. And right now we don't have any sample coolers over here, so that'll be a discussion that I have with the powers that be about installing those kind of sample points. Conductivity in the boiler water. Low conductivity means low boiler cycles, low TDS. Downside would be wasted water and wasted chemicals. If you're running too low cycles, you're not going to be able to get the alkalinity up to the spec you need. High conductivity, you're cycling the boiler up too high. Those dissolved solids are going to start to precipitate out. There's only so much that the chemistry can do. When you start exceeding those limits, the components in the water are going to become less soluble. Feed water, or the boiler pH, want to make sure the pH is in a good range so that it's not corrosive. Phosphate, like I said, that is your inhibitor, both corrosion and a scale inhibitor. So you want to keep an eye on the phosphate to make sure that's in range, and adjust your out-dispersed feed if need be. Silica, the high limit on the silica typically is about 180 ppm at this pressure. So another thing to keep an eye on to make sure you're not exceeding solubility limits. Doubtful we'll ever get to that, considering the cycles will likely be running at and what the silica in the feed water should be. Alkalinity, that is 300 to 800 ppm. So if you're blowing down too much, too frequently, your alkalinity is going to come down. And if you're not blowing down enough, your alkalinity is going to be above that 800. So that's kind of how we'll get a feel for how often we need to come over here and blow the boiler down, because that's going to you're going to want to keep your alkalinity above 300 to keep corrosion under control, but then above 800 you're going to start getting stuff depositing out onto heat transfer surfaces. So the other thing to keep an eye on is conductivity. So you kind of look at the conductivity and the alkalinity, and as long as we're where the conductivity control range should be, then most likely the alkalinity control range is going to be in spec too. And then iron, you want to check the boiler for iron, make sure there's no active corrosion going on and not high iron levels that could start depositing out on the heat transfer surface. The condensate, again, conductivity. High conductivity is a sign of a leak or overfeed of steamate Na702. pH, low pH, insufficient feed of the steamate Na702, and high pH, excessive feed of the steamate Na702. High hardness indicates a leak along with conductivity. So if you see high conductivity and high hardness, then you know you've got something in the building somewhere that's leaking into the condensate system and coming back. We also want to check the condensate for iron to make sure there's no active corrosion going on in the condensate system. And any iron that comes back with the condensate will eventually end up in the boiler and cycle up. So we want to keep an eye on those things. And then same thing with copper. We want to keep an eye on copper. That pretty much summarizes it all. Any questions?
I have a question.
Yes.
I don't really know amines too well, but are the intention for the amines, is it to protect the steam line or the condensate line or both?
Both, I mean, but the way you check it is through the condensate pH. That's the best way to check your amine feed and whether or not it's sufficient. And it will protect the condensate. Because if you don't feed amines, or if you've got an insufficient feed of amines, like if this wasn't on, if it wasn't feeding at all, pure water is a pH of 7. Carbonic acid gets introduced into the system through any leak anywhere, and then all of a sudden your pH is dropping to 5, let's say.
Damage the pipes.
Yeah, and then it'll start eating away at the metal. So, yeah.
How long are you gonna be involved with?